right, the next part of our lesson on complex numbers is dealing with complex conjugates and how we divide. We definitely talked about complex conjugates quite a bit last year. Complex conjugates, or just conjugates in general, just mean when I have two different binomials being multiplied together, or just a relationship that they're same thing except for one is positive, one is negative. And when I multiply these conjugates together, those two middle terms are always going to cancel out, which means we are going to take those complex conjugates and we know they multiply together into a difference of squares. The fact that they're complex though, my squaring of an imaginary number produces a positive number. So we're seeing this interesting pattern here. So a complex conjugate just means that one has a plus sign and one has a minus sign. And the reason why we do this is I can take two complex numbers, multiply them together, and they become real. To show you, 3 times 3 is 9, 3 times negative 2i is negative 6i, 2i times 3 is positive 6i, and 2i times negative 2i is negative 4i squared. But as we said earlier, whenever I multiply conjugates together, those two middle terms are going to cancel. And the only thing we need to do here is handle this I squared. I squared is the same thing as negative 1. So this is really just 9 plus 4, and 9 plus 4 is 13. So whenever I multiply complex conjugates, it allows me to take something that is two different imaginary numbers, or two different complex numbers, and multiply them together to get something that is only real. There's no imaginary part. Okay. So the reason why we need to know how to do this is because whenever I need to take a fraction, sometimes I might want to take that fraction and rationalize the denominator, or make that denominator real. And that's going to allow us to apply the multiplicative identity. So here we go. The multiplicative identity for the complex number is 1 is equal to 1 plus 0i. The multiplicative inverse or reciprocal of z is of a plus I is the complex conjugate. So what we're going to see here is that if I want to divide two numbers, I need to basically just multiply by the complex conjugate over itself so that I can take that denominator and make it real. So I'll kind of show you how this works. This might be one of the very few things that might be new. I can't remember if we did this a lot last year or not. That might be new based off of complex numbers. So it says write the complex number in standard form. And I'm seeing the denominator here is 3 minus I. Well, the complex conjugate of 3 minus I is 3 plus I. So if I were to multiply by 3 plus I over 3 plus I can do that because this number is just a fancy way of writing 1. And I know for a fact that when I do this, my denominator is going to become real because a complex conjugate times, two complex conjugates multiplied together is going to get me to a real number. So I'm going to multiply my numerators together. 2 times 3 is 6. 2 times I is 2i. And in the denominator, I'm going to think about my distribution. 3 times 3 is 9. 3 times I is 3i. Negative I times 3 is negative 3i. And negative I times I is negative I squared. But again, you're going to notice that those are going to cancel each other out. We already said I squared is the same thing as negative 1. So this is the same thing as 9 plus 1 in the denominator. So I have 6 plus 2i all over 10. That's not quite standard form. Remember, standard form is a plus bi. So I'm just going to take this fraction and split it into pieces. I have the 6 over 10 piece, which can be simplified to 3/5. And I have the 2i over 10 piece, which can be simplified to 1/5 I. But I do the same thing for b. I'm going to multiply by the complex conjugate. So I'm going to be multiplying by 2 plus 3i over 2 plus 3i. Hopefully you can see that pattern. I don't even need to worry about those two middle terms in the denominator. 2 times 2 is 4. Negative 3i times 3i is negative 9i squared. So there's my denominator. My numerator, 2 times 5 is 10. 5 times 3i is 15i. I times 2 is 2i. And I times 3i is 3i squared. Keep simplifying this. Remember, I squared is the same thing as negative 1, so this is just negative 1, and this is just negative 1. So my numerator, I have 10 plus negative 3, which is 7. I have 15i plus 2i, which is 17i. In my denominator, I have 4 plus 9, which is 13. Again, this is not written in standard form. In order for me to write this thing in standard form, needs to be in the form a plus bi, so I'm going to take that thing and I'm going to partition it. I'm going to have the 7 over 13 part, and I'm going to have the 17 over 13 part, but that's got the I attached to it. So there's dividing complex numbers. What I'm going to ask you to do is take a little bit of time here, try this once. Again, this might be, I can't remember, might be something new to you guys. I'm going to ask you to take this number, multiply by the complex conjugate of the denominator over the complex conjugate, and that way we can take this thing and put it in standard form. All right, here we go. Multiply by the complex conjugate of 2 plus I over 2 plus I. In my numerator, I end up getting just negative 1 plus 2i. Remember, I squared is just negative 1. And in the denominator, I ended up getting 4 minus I squared. Remember, I squared is just negative 1, so it's really 4 plus 1. Take that fraction, split it into pieces, and now I have negative 1/5 plus 2/5 I. And that's a good place for us to break as well. We looked at complex conjugates and how we can divide complex numbers. Last thing we'll be looking at is solving quadratic equations with complex solutions.